When the bleep are we going to use that?
Physics is mathematics in motion. Right now, my car is moving at a constant velocity of 10 meters per second. That's about 22.4 miles per hour. I am not accelerating, which means I'm not speeding up, I'm not slowing down, I'm moving at a constant velocity. Now, if I were to come to a stoplight, for example, I might experience acceleration. I'm moving from an initial velocity of 10 meters per second to a final velocity of 0 meters per second. I'm traveling 0 meters for as long as I'm sitting right here at this light. If it takes me 15 meters to come to a stop, using physics and math, I can figure out how long it takes for my car to come to a safe stop. Now, before we calculate, let's review some math skills.
Many students use the phrase, "Please excuse my dear Aunt Sally,"
Excuse me.
to memorize the order of operations. A simpler mnemonic device is Pemdas. Pemdas represents all of the operations in the proper order. The P in Pemdas stands for parentheses. This can be parentheses or any grouping symbol, brackets, or even those fancy pinky up brackets. The E in Pemdas stands for exponents. Now, we often think of exponents as just being powers, such as -3 cubed, or -3 in parentheses squared. But square root of 9 is also an exponent. Square root of 9 is the same as saying 9 to the 1/2 power. The M and D in PEMDAS are multiplication and division. They're lumped together and color-coded in this case because you do multiplication or division from left to right, whatever you see first. They work this way because they're inverse operations. They do the same thing in opposite directions. The A and S in PEMDAS represent addition and subtraction. You'll evaluate all addition or subtraction from left to right, just like multiplication and division. Whether you're evaluating a math problem or using math to describe motion, you're going to follow the same 3 steps. Once you have a completed algebraic expression, you're going to underline the first operation that you would follow. You decide which operation to evaluate using PEMDAS. Then you're going to evaluate the operation that you underlined, taking care of one operation at a time. Once you've evaluated or calculated that particular operation, you're going to rewrite everything else from the algebraic expression. This way, nothing is lost as you go through and evaluate the algebraic expression step by step. Once you finish evaluating that operation, repeat the process. Find the next operation using PEMDAS, underline it, evaluate it, and rewrite everything else. If you're still not down to a single value answer, then you're going to underline the next operation, evaluate, and rewrite until you have a single value answer. Everything that has ever been accomplished successfully followed a proper order. Building the Great Pyramids of Giza, slowly but surely winning a World Series, and of course, a trip to Taco Bell. Traditionally, you eat your delicious Taco Bell meal, visit the bathroom, and dispose of your delicious Taco Bell meal. But what if you didn't follow that order? What if you chose to eat your delicious Taco Bell meal, disposed of your delicious Taco Bell meal, and then visited the washroom? Whether it's math or bowel movements, order matters.
Excuse me.
If you rely on PEMDAS and stop excusing your dear Aunt Sally, you can find the distance traveled by a car moving at a constant velocity. Right now, my car is driving at 10 meters per second. My initial velocity was 10 meters per second. My final velocity was 10 meters per second. Because I'm not speeding up or slowing down, my acceleration is 0. Now, if I know that my car travels at this velocity for 20 seconds, I can find how much distance I've traveled. All I need is PEMDAS and the right formula.
In physics, we describe motion and calculate given distances velocities and times using the kinematic equations. For example, this kinematic equation can be chosen based on the given information in our current problem of a car driving at a constant speed or constant velocity. We know that the car is moving at an initial velocity of 10 meters per second. So B sub 0 is 10. Sub 0, that little tiny zero, often means initial velocity, initial position or distance, etc. It's a constant velocity, so we start at 10 meters per second, and our final velocity is 10 meters per second as well. We're traveling at this velocity of 10 meters per second for 20 seconds. Without diving too much into the kinematic equations, we see an order of operations problem present itself. Because x, or distance, is by itself, if we evaluate this expression, we'll know how far the car traveled. At this point, we set science aside and start to just calculate. So I'm going to follow the order of operations. I see parentheses, so I'm going to underline that. I'm going to underline, I'm going to evaluate, 10 plus 10 is 20, and I'm going to rewrite everything else. Notice that 10 plus 10 is now 20. I see 1/2 times 20, and then times 20 again. So I'm going to go left to right, multiplication. Underline 1/2 times 20, evaluate 1/2 of 20, and my calculator would be 10. So I get 10 times 20. I'm going to do it again. I only have one operation, so I'm going to underline, evaluate. 10 times 20 is 200, and there's nothing to rewrite because my final answer is 200. This calculation tells us a couple of very important things. It tells us the car was traveling at 10 meters per second, it was traveling at that velocity for 20 seconds, and that it would travel 200 meters during that time. As these lessons go on, you'll learn more about these variables, units, and formulas. For today, let's just focus on the math.
So, going back to our original question, if my car comes to a stop at a stoplight from an initial velocity of 10 meters per second over a distance of 15 meters, how long did it take for my car to come to a safe stop?
If I use my observations and the right formula, I can find how much time it takes for my car to come to a safe stop. Here's my formula. I'm looking for time. I know that x, my distance or displacement, is 15 meters. My initial velocity, v sub 0, is 10 meters per second. And my final velocity, because I came to a stop, is 0 meters per second. This formula is a rational expression. It looks like a big fraction. The top, the numerator, acts like a set of parentheses. The bottom, the denominator, acts like a set of parentheses. So Pemdas starts with parentheses as well. 2 times 15 is 30. I underline, I evaluate, and I rewrite. So the t, the equals, that big line, the 10, the 0 all come down. Now I'm going to take care of 10 plus 0. Underline, evaluate, 10 plus 0 is 10, and then I rewrite 30 over 10. Final operation is just division, so I took care of my parentheses. There's no exponents. I'm going on to multiplication division from left to right. 30 divided by 10 is just 3. Mathematically, my answer is 3 seconds. But from a physics point of view, I know that if I start at a velocity of 10 meters per second and I come to a stop over 15 meters, it'll take me 3 seconds to come to a stop. Physics is math in motion. Your values are not just numbers. They represent something. How far, how fast, or how much time.
As I leave the stoplight, I accelerate forward from an initial velocity of 0 meters per second to 15 meters per second over the course of 10 seconds. I challenge you to calculate my acceleration using the following formula and the order of operations. In physics, we use the kinematic equations and order of operations to evaluate velocity, the speed of an object in a given direction, displacement, the distance an object has traveled, acceleration, an object's change in velocity over time, and the time traveled by the object.